Now let us see the generalized definition of trigonometric functions of any angle in general. So here we consider a standard circle, that means it's a circle having its center at origin as shown in the figure and the radius r. Now let us consider any point P in general on the circle whose coordinates are x and y. So here we define the cos of the angle which the radius OP makes with positive direction of x-axis. So here we can see the angle theta. The cos of that angle theta is defined as the x coordinate divided by the radius r, whereas sin theta is defined as the y coordinate upon the radius, right? Now moving on, tan theta is defined as the y coordinate upon x coordinate. Cot theta is the reciprocal, that is x coordinate upon y coordinate. Then sec theta is defined as the radius upon the x coordinate, whereas the cosec theta is radius upon the y coordinate. Now you may wonder, isn't it same as what we studied in school time, where cos theta was defined as the adjacent side upon hypotenuse and so on. So here when I say cos theta is x by r, isn't it x as the adjacent side of theta and r is the hypotenuse? But we have to keep in mind one thing, that that particular definition of referring to opposite side, adjacent side or hypotenuse was confined only in case of right angle triangle. So that means if we want to find the trigonometric ratios of angles which are bigger than 90 and so on, so in that case that particular definition will not hold, because you will never have an obtuse angle in a right angle triangle. So therefore we have generalized the definitions of trigonometric function as shown here in the figure. So therefore now, because of the generalization, even if the point where at some other place, say consider that point is in second quadrant somewhere on the circle as shown here, we still draw the radius. Okay, so therefore now we have another angle theta. Okay, now if you consider the tip of that particular radius on the circle, its x coordinate will be as shown here and its y coordinate will be as shown here. So clearly it is the negative x coordinate and it is the positive y coordinate. So since we are defining sine, cos and all other ratios in terms of just x and y coordinates, we need not worry whether the angle is in first quadrant, second quadrant or any other quadrant. So the definitions of the trigonometric functions remain same for any angle, right? So having that said, let us go ahead to find out what will be the signs of the different trigonometric functions if the angle lies in the different quadrant. Let's consider some angle in the first quadrant, correct? Now here it is clear that the x and y coordinates are both positive. So that means sine and cos both will be the positive functions. So therefore all the remaining four functions derived from sine and cos will also be positive. So that is where we remember that all ratios are positive in the first quadrant. Now let's consider some angle which is present in the second quadrant. That means we are talking about an angle whose measure is between 90 degrees to 180 degrees or pi by 2 radians to pi radian. So in this case we see that x coordinate is negative and y coordinate is positive. So that means since y coordinate is positive, which represents the sine ratio, isn't it? So therefore we remember that sine is positive in the second quadrant, and of course that makes cosec also positive because cosec is 1 upon sine. So apart from sine and cosec, all other ratios will be negative because x coordinate is negative. Now coming to third quadrant, we observe that both x and y coordinates are negative. So that will make the tan and cot as positive. So therefore we remember just that tan in case of third quadrant to be positive, and sine, cos, sec and cosec, those four will be negative in the third quadrant, and tan and cot will be positive. And lastly, in the fourth quadrant, if you consider some angle, here we see that y coordinate is negative, whereas x coordinate is positive. So since x coordinate is positive, that means it is the cos which has to be positive ratio, and hence sec, which is also will be positive. So therefore the remaining four, that is sin, tan, cot and cosec, will be negative. So now here we develop a small mnemonic to remember these signs. So from the first quadrant we have all, so we take A. From the second quadrant we take S. From the third quadrant we take T, and from the last quadrant, fourth quadrant, we take C. So you can remember this particular mnemonic with a simple statement, that is all students take coffee. So that's a simple way to remember the signs of various functions in different quadrants. So all students take coffee. ASTC.